British Rail's Class 28 appeared to have an unmistakable problem. Its Crossley two-stroke engine could discharge an extraordinary plume of black smoke. Engineers found a way to make the exhaust cleaner, but that apparent cure placed still greater loads on machinery already struggling to survive. That makes the Metrovix story more revealing than a simple tale of a bad diesel. 20 locomotives entered service with an unusual engine, Britain's only co-bow axle arrangement, and serious expectations. Within a decade, 19 had gone. The 20th survived through a remarkable accident of reuse. Why did British Rail accept such an unconventional machine? Why did a locomotive intended to test new technology reach fleet service before its weaknesses were resolved? And why did changing the combustion timing force engineers to choose between visible smoke and damaging internal pressure? The answer begins with the 1955 Modernization Plan. British Railways intended to replace steam rapidly, but it did not yet possess a settled design for the national diesel fleet. The pilot scheme therefore ordered competing locomotives from several builders, power ranges, and transmission traditions. In principle, that diversity created a national experiment. Diesel-electric, diesel-hydraulic, and diesel-mechanical systems could be tested in real service. Different engines could compete under British conditions. The strongest combinations would then guide larger orders. It was an attractive idea provided the experiment remained genuinely controlled. In practice, dieselization gathered speed before every pilot result was available. Builders needed orders, regions needed locomotives, and political pressure favored visible modernization. Experimental variety entered a railway that would ultimately need standard spares, trained fitters, and dependable fleets rather than a museum of incompatible engineering solutions. Metropolitan Vickers received an order for 20 Type 2 diesel electrics, numbered D5700 to D5719. They were constructed at the company's Bowesfield Works in Stockton-on-Tees during 1958 and 1959. Later classification would give them the familiar designation British Rail Class 28. Their external form was already distinctive. A long, slab-sided body stood on two unequal bogies. At one end were three powered axles, at the other, two. In railway notation, that was CO-BO, 5 traction motor axles distributed asymmetrically beneath one locomotive. No other British rail class used that arrangement. 5 powered axles offered substantial adhesion for a locomotive producing only 1,200 horsepower, while the unequal bogies helped distribute equipment weight. But this visual oddity was not the reason the class acquired its troubled reputation. Inside was a Crossley HST V8, a low-speed 8-cylinder 2-stroke diesel developing 1,200 horsepower at 625 revolutions per minute. Metropolitan Vickers supplied the generator and electrical equipment, while 5 direct current traction motors turned the 5 powered axles. A 2-stroke engine completes its operating cycle in 1 crankshaft revolution rather than 2. That can offer a favorable power-to-weight relationship, but the cylinders must be cleared of exhaust and refilled with fresh air efficiently. Poor scavenging can contaminate the next combustion event. The Crossley engine had no conventional inlet and exhaust valves. Ports in the cylinder walls controlled gas flow as the pistons moved. Exhaust pulses were also used in the pressure charging and scavenging system, making the timing and condition of the gas path critical to clean combustion. This was not technology selected from nowhere. Crossley's H-range engines had already found railway applications in Western Australia and Ireland, although their later histories would also involve major modification. To British Railways, the design offered a domestic 2-stroke alternative at a time when foreign currency remained constrained. The Metrovix therefore represented a serious comparison, not an eccentricity commissioned for spectacle. Their 2-stroke engine could be measured against the 4-stroke diesels becoming more familiar on British locomotives. Formal Metropolitan Vickers and Class 28 test material remains listed in the National Railway Museum's Technical Archive. Early assignments gave the class work worthy of that ambition. Metrovix became associated with the Condor, the overnight container train between London and Glasgow. This was a prestigious, time-sensitive freight service demonstrating how rail might compete in a changing transport market. A pair of 1,200 horsepower locomotives could provide 2,400 installed horsepower, while their 5 powered axles gave useful adhesion. The image was compelling. Modern container traffic behind modern diesels, displacing steam on exactly the kind of service the modernization plan wanted to transform. But a locomotive can look modern in a publicity photograph while creating an entirely different impression inside a maintenance depot. The Crossley engine soon developed failures involving their fabricated crankcases, cylinder heads, piston crowns, leakage, and components within the gas transfer system. If you enjoy engineering stories that separate a machine's real mechanism from its reputation, like this video and subscribe. The Class 28 becomes most interesting when its notorious smoke is treated as evidence rather than the whole explanation. One weakness was visible to almost anyone near the railway. The locomotives could produce dense black exhaust. Incomplete combustion supplied the obvious symptom, but the underlying system was more complicated than merely giving the engine too much fuel. Transfer valves were intended to prevent exhaust gases from forcing their way into the inlet manifold. These components could become blocked or suffer fatigue fractures. When scavenging deteriorated, the engine could emit the spectacular dark plume that came to define the Metrovix in enthusiast memory. The obvious engineering desire was cleaner combustion. Tests advancing the injection timing by 3 degrees did improve the exhaust. Fuel began burning earlier, allowing combustion to proceed under conditions that reduced the visible smoke. Yet the pressure inside the cylinders rose sharply. A technical heritage review records peak pressure increasing from about 1,100 to 1,400 pounds per square inch under the 3-degree setting. That cleaner result overloaded the white metal main bearings. The cure for one highly visible fault therefore intensified a less visible mechanical threat. A compromise of 1.5 degrees advance was adopted. It reduced the pressure penalty, but it also accepted dirtier exhaust than the full 3-degree setting. Engineers were not choosing between a defective and a perfect adjustment. They were balancing two consequences created by the same combustion system. This is the Class 28's central paradox. Smoke was not simply neglected because nobody knew how to reduce it. Cleaner exhaust demanded internal loads that the existing bearings and structure could not comfortably withstand. Moving one limit exposed another. Nor was the engine the only source of embarrassing trouble. The original cab design used outer front windows that wrapped around toward the sides. Reports of windows coming loose in service led to modification, replacing the curved arrangement with flat panes facing forward. That change created two visually distinct Class 28 identities. Early locomotives had wraparound corner glazing. Modified examples had flatter, more conventional cab fronts. Any reconstruction mixing the later windows with an unqualified early service scene risks compressing several years of remedial work into one false image. By 1961, the scale of the engine problem required the whole class to return to Crosley's Dukenfield works. Strengthened crankcases and cylinder heads were fitted during a major refurbishment program. This was not routine attention to a few troublesome examples. Every engine required intervention. The program demonstrates that neither British Railways nor the manufacturers abandoned the design at the first failure. Money and effort were committed to saving it. Yet refurbishment could strengthen damaged components without necessarily removing the relationships that had produced those loads and failures. One locomotive reportedly received a completely redesigned crankcase that proved satisfactory. By then, however, the decision surrounding the class was larger than the fate of one improved component. 20 non-standard locomotives had to compete with diesel families accumulating greater numbers, stronger support, and improving reliability. That is where the pilot scheme changed meaning. Diversity is valuable while evidence is being gathered. Once a railway chooses its fleet, diversity becomes inventory, training, and availability cost. A rare engine with specialist weaknesses must offer something exceptional to justify remaining outside the emerging standards. The Kobo arrangement gave the Metrovic individuality, but it could not compensate for an unreliable prime mover. 5 traction motors and strong maximum tractive effort were useful only when the engine, generator, auxiliaries, and controls were all ready for service. After their earlier mainline duties, the locomotives became strongly associated with Cumbria and the former Furness railway routes. This move did not transform them into successful standard locomotives. It concentrated a small class where operational and maintenance arrangements could contain some of its non-standard character. Their maximum speed was 75 miles per hour, appropriate for a Type 2 mixed-traffic locomotive rather than a high-speed express machine. They could work passenger and freight trains, but their modest power and poor reliability left little strategic reason to fund another fundamental redesign. Withdrawal followed with remarkable speed. The class entered service in 1958 and 1959. Regular withdrawals came during the later 1960s, with the fleet gone from ordinary service by 1968. Most members had therefore worked for less than 10 years. It is tempting to reduce that outcome to one sentence. The engines smoked, so British Rail scrapped them. The evidence supports a harder verdict. Smoke revealed defective scavenging, while attempts to improve combustion exposed bearing limits within an engine already suffering structural and component failures. British Railways had also ordered a fleet too small to absorb expensive, continuing redesign once more successful types were available. Technical weakness and system economics reinforced each other. The engine needed investment precisely when the railway was learning that it needed fewer varieties, not better versions of every unsuccessful pilot. 19 Class 28s were scrapped, but D5705 escaped their immediate fate. It was renumbered S15705 and transferred to the research department, where it became part of the tribometer test train. That role required a useful vehicle, not necessarily a dependable original propulsion system. A tribometer vehicle investigated the relationship between wheel and rail, including adhesion and braking conditions. D5705's unusual second career shifted its value from hauling ordinary trains to supporting experiments. The failed fleet member survived because the railway found a purpose detached from the original Type 2 competition. Later, it became Stationary Carriage Heating Unit TDB 968006 at Bristol Bath Road. Once again, survival came through subtraction. The locomotive no longer needed to prove that its Crossley engine could sustain mainline duty. Its body and heating equipment remained useful in a far less demanding role. By the early 1980s, photographs showed the departmental survivors stored at Swindon Works. It looked more like an overlooked industrial relic than the sole representative of a once prestigious diesel experiment. Preservation eventually secured it, allowing D5705 to outlive every apparently healthier classmate. Today, it remains the only Class 28 cared for at the East Lancashire Railway under the custodianship of the Class 15 Preservation Society. Its surviving body preserves the unequal bogies, modified cab front, and physical scale that diagrams alone cannot communicate. Restoration also confronts an unusual choice. Returning D5705 to operation is not merely a cosmetic task. The very machinery that makes it historically important is machinery whose weaknesses helped eliminate the class. Authenticity, reliability, cost, and the survival of irreplaceable components must all be balanced. That gives the survivor a significance beyond rarity. D5705 can explain how early British dieselization actually proceeded. Multiple builders, competing engine philosophies, bold operational trials, rapid modification, and equally rapid rejection when the national fleet began to standardize. The Metrovic was not useless. It hauled real passenger and freight trains, worked the Condor, supplied valuable comparative experience, and later supported research. Calling it useless erases the evidence generated by its operation and the work performed between failures. But describing it merely as a misunderstood success would be equally misleading. An engine that requires fleet-wide rebuilding continues to present inherent difficulties and cannot deliver dependable service has failed an essential locomotive requirement, however interesting its individual ideas may be. The fairest verdict is that the Class 28 exposed the cost of learning too quickly at fleet scale. British Railways wanted experimental evidence, but it also needed working locomotives immediately. 20 pilots became operational assets before their engine had demonstrated that its compromises were acceptable, and the black smoke, memorable though it was, should not receive the final word. The most revealing moment came when engineers made the exhaust cleaner. Cylinder pressure rose, the bearings objected, and the apparent cure revealed that the problem extended far deeper than anything visible above the roof. Subscribe for more British locomotive history, and tell us which Class 28 outcome you would choose. Preserve the original Crossley engine without running it, operate it under strict limits, or fit reversible modern protection while retaining the historic machinery. D5705 survives because British Rail stopped asking it to be an ordinary Class 28. First research work, then stationary heating, and finally preservation separated the locomotive from the duty its design could not sustain. Britain's only Kobo was saved only after its original fleet had lost the argument.